Hello and welcome to the lesson on principle of superposition. What's today's goal? I can explain and apply the concept of superposition in terms of wave interference and predict the resulting destructive interference. So I have an applet here for you. I put it on the website. You can click on it. You can pause now if you want to go play with it. It's the same one that we talked about in terms of wave behavior. Actually, that's not true. There's some other stuff on that one as well that's neat to see. So I've got in the PDF some of the printouts, but I do recommend playing with it a little bit just to see. And I'm going to go through and I'm going to outline what you should have saw if you go through and play with it. So first of all, what do we have in front of us? We have 2-point sources, similar to what you would have seen when you did your investigation on the wave behavior or wave theory. And what I want to do is talk about exactly what is created here. So what we have are, got 2-point sources. And if this was a tub or a pool, I'd be asking her that what I'm interested in most is this region right here or this region right here. What is this? Okay. We know from the applet that the blue lines are crests, yellow are troughs, or whichever you want to go with. What are those black spider-like regions there? Well, what they are points of destructive interference. Okay, so we have points of destructive interference. Now, what happens when you have a bunch of points of destructive interference? What happens? Those points, first of all, they are called nodal points. Slip that in there first. So a series of nodal points create nodal lines. And those are lines of destructive interference. Okay, so those regions, if you're floating your rubber ducky in the tub here, if the rubber ducky was in any of those green regions that I have outlined here, the rubber ducky wouldn't be going up or down. Okay, the rubber ducky would be staying stationary because there's no waves there. There's destructive interference. There's crests and troughs meeting at those points. If you play with the applet, you can see that you can change those nodal lines depending on frequency, wavelength, etc., etc. So do take some time to play with the applet just a little bit to see how those nodal lines interact or relate. So interference. We have 2 types of interference. We have constructive interference, which is when waves, crests interact or troughs interact, so it increases the amplitude. And then we have destructive interference, where waves in a cycle decrease the amplitude of the crest or the trough. So a couple of things I want to point out here then. We have 2 waves interacting. Okay, we have the red and the blue one, and the yellow is our resulting wave. Okay, so, and it'll be black and white for you, so you may want to maybe make sure you note that. So yellow is the resulting wave. So what's happening here? If you were to add the values at those particular points, so for example, let's go right there, right there, right there, those 3 regions, if I was to add up the amplitude, here it's 0 plus 1, the amplitude is 1, so that's why the yellow line is there. Here, I would say they're both 0.7 plus 0.75 plus 0.75, which gives you 1.5, which is why the yellow line's up there, and 0 and 1 is 1. So, first thing I want to note here is that the new wave has an amplitude equal to the sum of the interacting waves. So if you add the amplitudes, you will end up with your new wave. Okay? Secondly, if you try the applet out, okay, you'll notice that the interaction of waves does not change the original wave. So what that means is that when these two waves interact, overlap each other, when they exit, the blue wave will be the exact same as it was before, and the red wave will be the exact same as it was before. So even though they interact or smash into each other, cross each other, it doesn't change their properties. For a moment in time, they share amplitudes, and they create constructive interference. But once they pass through each other, it's status quo. It's back to the way they were. All right. So when we look at the next example then, here we have destructive interference. I guess we have a little bit of everything going on here. I have 3 slides before. Here's our constructive interference. So we'll put example of constructive interference. All right, and we'll just say see prior slide. So we've already talked about it. All right, the next one. Here's the example of 2 waves that have passed through each other. And you'll see that there's no change. Okay, so they pass through each other. They have the exact same properties as before. And finally, the last one is destructive interference down here. An example of destructive. So example of destructive interference. And when you look at it, you can say technically the blue wave has negative amplitude. So the resulting wave is still the sum of amplitudes. So the resulting wave is still the sum of amplitudes. But because they're equal and opposite, the result is no amplitude at all, no wave. So identical amplitudes will result in total destructive interference. Oops. So destructive interference means that we end up with no wave at all when they interact. Constructive interference, we end up with what's called a supercrest or a super trough. So call that a super crest or super trough. So when we have that complete constructive interference, we call them supercrests and super troughs. All right, and that's the counterpart or the opposite of a nodal point. So there we are. So as we move on, you can see here I went to standing waves, some examples of standing waves. So examples of standing waves or continuous pulses. Standing waves or continuous pulses. All right, so what does that show us? Well, if we take a look here at these continuous pulses, I already have my lines matching up, so I made sure the graphs matched each other. When we have our supercrescent super troughs being formed here and here. So I'll put that as point number one. That's super trough. All right. In the next sequence, you can see that the waves now are out of phase. So we have complete destructive interference. Okay. So in phase number two, we have complete destructive interference. Destructive interference. And number three, we return to that final, back to our supercrescent super troughs, but at new locations. So super crests and troughs at different locations. Okay. So when you go through this applet, this is the applet, it's screenshots from that applet. You can change the amplitude to make them equal or unequal. You can put them in or out of phase, and you can pause it. You can make it pulse or continuous. So do go ahead, make sure you play with that applet a little bit just to see what this looks like in live time. And if you have any questions with that, let me know, and we will. I'll finish this lesson off in the next video.